ladies and gentlemen, this is going to be M7, okay, and this is lesson 6-6, and what it's called is percents as equations. Now, I want to review a few things with you before we get started here, is to kind of get our brains moving a little bit. And so to do that, I'm going to put a percent up here, and I'm going to want you to write it as a decimal, and I want you to write it as a fraction, okay? So the percent is 34%, okay? Go ahead right now, write this as a decimal, and write it as a fraction. And you don't have to do it in that order. It should be in simplest form, yes.
So fraction.
Fraction and decimal. Now, I will say the decimal should be the easy part. The decimal is the easy part. Because the decimal, well, I won't say. The decimal is the easy part. Okay, does someone want to give me the fraction? Miss Lixon?
17 over 50.
That would be very good. What did you start with to get to that?
34 over 100.
You started with 34 over 100. That's very good. That's what I would have done. And then you saw what goes into both. 2. 2 goes into both. 34 divided by 2 is 17. And 100 divided by 2 is 50. And that is the simplest form of this particular percent in a fraction. So it's very good, Miss Lixon. Nice job. Now, what about the decimal version? The decimal version. Hannah Harvey.
0.34.
Yeah, nice job. All you did was move the decimal, right? So you take a 34% and you just say, I'm going to move that decimal 2 places, and it becomes 0.34. So nice work. That's exactly what I was hoping for. Okay, that's what we're going to focus on today. Okay, that's what we're going to focus on today, is the decimal version of any percent. And this is really something that you can use a lot, okay? So let's go ahead and get started with our lesson. I'm going to go ahead and write a statement up here, and we're going to use an equation or develop an equation that'll help us to solve it. So here's the statement, and please write it down. What is 15% of $8.76? Okay. Why might we want to find 15% of $8.76? Where might this actually be useful to you? Your parents do this a lot, actually. Gabby?
When you're going to like the store and there's a sign that says 15%.
Okay, so 15% off at a store. That's a great example of this. Where else might we use something like this? Yeah. Go ahead. Do you guys ever go to a restaurant?
Yeah.
Did you know that waiters and waitresses don't make a lot of money? Where do they make most of their money? Tips. Standard tip nowadays is anywhere between 10 and 20%. Some people... Well, that's a great tip. So oftentimes people leave kind of the basic now is 15%. It's kind of the minimum. And a lot of people leave up to 20% as a tip. So let's pretend that we're leaving a tip, or that we're finding 15% off. 15% of $8.76. Well, we could set this up 2 ways. I'm going to set it up like you would have set it up using the previous lesson where we have a proportion. Okay? So if we were to set it up as a proportion, we'd have a line equals a line. What number is always included in our proportion? Yeah, 100. And it's going to go in the bottom. Okay? And because they give us the 15%, where am I going to put that 15? Hannah? Over the 100. Very good. Then, okay, they give us this $8.76. Okay, where's that going to go? Is that my part or my whole? Lixon?
It's your whole.
It's my whole. So that's going to go down here. And I'd solve by putting x up here. Okay? So why don't you right now go ahead and do this. Yep, so you'd cross multiply and solve. So go ahead and do that. Take maybe a minute or two and solve it. You are allowed.
So this is what we did last.
Uh-huh.
Yeah. 286.
Yep.
Doesn't matter which side you do it on.
Cross multiply.
So on the 100.
100x.
No. Like when you are writing the actual portions.
Oh, so long as the 15 is over 100, you're fine. So no, you could have them flip. That would be, I like to keep things as simple as possible. But Ms. Lixon, that is a crafty way, and yes, you can do that. Okay. You did something wrong? Oh, that's good. We learn from mistakes. Oh, I love mistakes. All right, what is your question?
Okay, so guys.
A in 5, 4, 3, 2, 1. There's a question. It might benefit you to hear this question. Go ahead.
So you know how the 100's on the bottom?
Yes.
And then like sometimes it's on the top. Like
No.
What?
100's always on the bottom. It's always your whole.
Like somehow. I'm confused now.
Okay.
So the 100 is always on this corner. It's always there.
The 100 is always,
On the bottom.
yes.
Could it be on this side of the bottom?
It could, but it has to be on the bottom.
But it has to be. So
It does.
Oh, when I'm talking about the X, could the X be on the bottom? Could the X be somewhere? Yes.
The X can be on the bottom if you're trying to find a whole.
And then the part. Like how does the X on the bottom change if it's a whole or a part?
If you're trying to find a whole, X is on the bottom, and it just changes how you cross multiply and what you do after that.
So you put it on the bottom, 8, so it'll be 100 times 876.
Yes, but that's not what we're trying to find here.
Oh, okay.
Okay? All right, so what did we get, Izzy? X equals $1.31.
When you do 15 times 876.
Divided by 100.
Yeah, I know, but why does it go to $131?
It doesn't. You got to divide by 100. You cannot look at the problem until you've completed it.
No, I know, but when you do, why does your bill, no, when you do 15 times 874, why does your bill go from 876 to 100?
It doesn't. It doesn't. It's just math. It's just a means you get from point A to point B. You have an $8.76 bill, and you're going to pay $1.31 in a tip. So how much would you pay total if you were to tip 15%? Yes?
You would get
$10.07. Fantastic. Nice work.
How'd you get that?
You would add what you owe, and you would add the tip to that. So $1.31 plus $8.76.
You don't learn that.
You add the tip amount to the total amount to get how much you would pay out of pocket. So your bill is $8.76, but then you're going to pay an additional $1.31 to that waiter or waitress for their service. So a bill with a 15% tip in this particular situation would be a little bit over $10. Okay? Now, there's another way to do this that's a little bit easier. Okay? And let me show you what this looks like. Okay? Where we were doing something like this, this was the equation we were working with. However, we can change this a little bit. Okay? Here's how this works. I'm going to change it so that it equals the part over the whole equals the decimal version of the percent. The decimal percent is what we call this. Okay? So, give you an example of this. Okay? Let's say that you had 15 over 100. Okay? 15 over 100. I'm going to do the example in red. So we have part over whole equals 15%. We don't know what the part or the whole is. Can you guys do 15 divided by 100 on your calculator? 100. It is. Yes, but let's go as a decimal. We're looking for a decimal. I'm going to let Gretchen answer this one. 15 divided by 100. You're just going to move the decimal 2 places. 0.15. Okay? So, when I say that we have the part over the whole equals the decimal percent, what I'm talking about is just writing the percent as a decimal. Okay, so that's what I mean by that. How would I, now let's just, to kind of make it a little bit simple, let's, instead of saying part and whole, let's use the letters P and W. Okay, so P over W equals the decimal percent. So if I were to use my example in red, I'd be P over W equals 0.15. How could I get P by itself? What could I do to both sides to get P by itself? Look at the red version there. What could I do to both sides to get P by itself? Gretchen? Well, I'm not going to divide. I'm going to do the opposite of division, which is, and I'm going to multiply by what? What is near the P that I need to get rid of? Savannah? No? The W. Right, it doesn't matter. I can move letters around if I do the opposite operation. So if P is being divided by W and I want to move W to the other side, I can multiply both sides by W. So I'm going to do that. W over 1 times P over W equals 0.15 times W. Okay. Now, I'm going to go ahead and highlight the thing that I'm multiplying by both sides. I'm multiplying W on both sides. What happens to the W's on the left-hand side? Anybody? Gretchen? Okay, what's your question? How did I get the what? I can write anything over 1. I can. I can do Gretchen over 1. I can do Parker over 1. I can do P over 1. I can do W over 1. It doesn't change anything. It doesn't change anything. I'm only doing that because that way it lines up when I'm trying to multiply the fractions. Okay? So I'll even make it easy for you. This is over 1 and this is over 1. I can do that. Now I have 4 fractions. Okay? What happens to the W's on the left? Gabby? They cancel. Because 1 is in the top and 1's in the bottom. What does that leave on that side? Yeah. Okay, what's your question? We are trying to find an equation that's super simple. Okay? When this is all said and done, this will be half the work of the proportion method.
Don't we get the question first?
This is going to solve the question.
We don't know what the question is.
I'm showing you, if you read we're trying to create an equation to use. Okay? To get the equation, we have to start with what we know. So, this is what we call a derivation. It's we start with something we already know and we make it simpler. Okay? So in this particular situation, I am just rearranging things to make a new equation that is half the work of the old way to do it. So that when this is all said and done, I only have to plug in 2 things, not 4 things, to solve for my percents. So, what am I left with on the left-hand side if the W's cancel? What is the only thing left? Hannah? P and 1. Okay? So, I'm going to be left with P over 1 equals 0.15 times W. And all of that would be over 1 as well. Do I need the 1's now? No, I don't. Because I'm not doing anything with them anymore. So what I am left with is P equals 0.15 times W. Okay? Here's what this means. I'm going to go ahead and go to a new page in just a second. Make sure you get this down. That's the equation we're going to use. And I'm going to show you how it works, and it's beautiful. It's beautiful. What that means is this. The part is always going to be equal to the decimal percent times the whole. That's it. The part is always equal to the decimal percent times the whole. So, if I wanted to find 15% of $8.76, I would just plug in the following. The part is equal to 0.15 times 876. That's it. Go ahead and multiply those two things. That's it. Yep, it just becomes one multiplication problem. What are you confused about?
Like, okay, so why do we have to go through all that other stuff?
Because that's where this came from.
So we're gonna have to put all that other stuff out.
No, but you have to understand where this comes from.
So you're just explaining how you got there.
Yeah.
That's what the other class is trying to teach us.
Uh-huh.
Wait, so this is all we have to do we only have to do 0.15 times $8.78.
That's it.
So
That will, and then what does it give you? 131, right?
what if it doesn't give you the percent?
It will always. Or if it doesn't, then you just treat it like a simple equation. You just treat it like a simple equation.
Oh, this is easy.
Okay, so what did this equal? Just someone tell me. Yeah.
1.3.
Yep, so the part was equal to 1.31. Hey, so that worked this time. All right, so let's take a look at this. Let's say that you're trying to find 33% of 76. Okay, what is the decimal version of 33%? Noah Miller. 0.33. So what two numbers do I have to multiply to get the answer? Yeah.
0.33 and 76.
That's it. You just multiply the two.
So we just have to change the
You just have to change the percent to a decimal and multiply the whole. So plug it in. Part equals 0.33 times 76. And what do you get as an answer? Elizabeth Lalonde?
I actually had a question.
Hang on one second. I want the answer to this. Caitlin?
25.08.
So what is 33% of 76? Gretchen? 25.08. I just multiply the two. So long as it's in decimal form, it works. Now, Elizabeth Lixon came up with a really good question. What if you're trying to find the decimal? Okay, what are the percent? Well, here's how that works. Okay, so I'm going to go ahead and do a little bit of a problem over here on the other side. Let's say we have a question like this. What percent is 13 of 74? Okay, what are they giving me here? Part, whole, or decimal percent? Okay, what are they giving me in this problem? Gabby? All right, what's the part?
13.
Okay, so the part is 13. What's the whole? The whole is 74. So I write my equation, P equals decimal percent times whole. Which two pieces do I know? Yeah. The part and the whole. So plug those in. 13 equals, do I know the decimal percent? in this problem? No. What do I use when I don't know something? Yeah, Savannah. I could use x. X times, what's the whole here? Yeah, Hannah. 74. Hey, this is the same thing as 13 equals 74x. How do I get x by itself? This is like an equation from like weeks ago. This is like the simplest equation I've given you. Yeah, how do you find x? Yeah. Yeah, divide both sides by 74. So, let's do it. Divided by 74. Divided by 74. These cancel out. What's my decimal percent equal? What's 13 divided by 74? Savannah?
Do you want the rounded version or the long version?
Do the rounded to two decimal places.
0.176.
And if you were to write that as a percent, what would that be? Yeah, Savannah? 17.6%.
Wait, why would it do 1
Because you only move it two places. The decimal only gets moved two places.
2 places?
All right, Izzy, what's your question? So basically, there's only three parts you need to know. And you're only ever going to be given two of them: the part, the whole, and the decimal percent. And that's it. And then you just plug in. You will always be given two of them. You plug in 2 and solve for the third one. Okay? You solve for the third one. It's really not as bad as you might think. Take a look at your homework tonight. It's going to be on page 300-ish. Is this it? Okay. Shh. Right now, with the person next to you, I want you to do number 7. Do number 7. They're going to give you two pieces of information. You're going to find the third. I would recommend writing this equation down at the top of your paper.
Wait, on the top of our assignment or on top of our notes?
Both places would be a good place, Mackenzie. That's a good question. I would put it at the top of your assignment, though, just so it's easy to see. So do number 7. Identify what pieces they're giving you. If I were to set this up, this is what it would look like. Okay. Decimal percent.
You could have done that for the other stuff.
All right, so I'm looking at this problem and I'm reading it and I'm like 96%. Oh, they give me the percent. So I just have to turn it into a what? Decimal. So I'm thinking the decimal percent for this problem is 0.96. Then they're giving me of what number is 24. Ooh, this is tricky. But the instructions say find the whole. So what am I trying to find? The whole. So the number 24 must be the what? The part. Yeah. And because I don't know the whole, I'm just going to call that, because it's my unknown, I'll call it x. So then I just plug all of this into my equation. So the part is 24. The decimal percent is 0.96. And the W is x. This is what I do for every problem I solve like this. This is what I call my toolkit over here. It helps me organize every problem. This becomes increasingly helpful when you get to things like Algebra 2, physics, or chemistry.
Wait, do you have to do the first step on that?
I would recommend it. How do you get x? How do you get the whole? Savannah? Yeah, how do I find it?
Well, you gotta divide both sides by 0.96.
And it's going to be probably in the 30s, low 30s.
20.
Oh, you did you?
I got 23.04.
Oh, that's fine. It should be larger than 24.
I got 25.
25? Okay, good job. Okay, so that's it. So 25 equals x. So what is my whole? 25. That's fine. So long as you say the whole and the end is 25.
Oh, we have to.
So they're always going to give you how many pieces? 1, 2, or 3? 2, and you're always going to have to find the third piece of information.
What about the
There's no 100 in this one. That's the benefit of this over the proportion method, because we need less information.
how do we have to do that with like the part half or the decimal point divided by a decimal point, and then you do the decimal point divided by the whole part?
You plug in your information and solve it like a normal equation. It's going to be different every time. Okay? It depends on what you're trying to find. And each time, there's probably at least, there's either going to be multiplication or division, though, never addition or subtraction. Let's do another one, just so we can practice this. Let me give you one. Do 16. Do 16. This is going to be in your homework. Yep. I did it on 10. I'm not oblivious, thank you very much. 16. Okay, set up your problem. Set up your problem. Identify the different pieces you're going to find. Number 16. You've got to identify what pieces they're giving you. Are they giving you the part? Are they giving you the whole? Are they giving you the percent? I will.
Okay, so it gives you the part and the whole, so you'd have to like
All we do is decimal. We do this the same way?
Yep, same way. It's going to be a little different this time around. But ultimately, the math is almost exactly the same. All right, so do they give you the whole?
okay, yeah,
Okay, what is it?
490.
Yep, so write that down.
Wait, sweet.
Hang on one second.
And then the part would be 124.
Yep, so what are you trying to find?
The decimal point.
Yep, so pick a letter to represent that. Okay, and then use your equation and just plug in the two pieces you're given and find x. So go ahead and set it up and see if you can solve it from there. I'll double check it in just a minute. Yeah. Yes, that's exactly it. And so then what would you do? It doesn't matter. How would you get x by itself? It doesn't matter if it comes first or second. The same math is going to work here. So what would you do? Yep, and then, yeah. Good, good, good. Yeah. Yeah.
So if I do it on like the shorter version on like the homework, would you still count that?
If you did that, I would love it.
All right.
I can see what you're doing. Nope.
Okay.
Yep, so then, now, that is actually going to be your, yep, because that's what you said it was. Let's see. Okay, so remember, your whole is almost always going to be your bigger number.
Yeah.
So whole is always over here with the decimal percent.
That's what I did first, but why would you divide 124 by 496?
So you can get a percent.
Wouldn't that be really, really low?
No, because it's a decimal percent. It's going to be the decimal version of the percent. But yes, it would be you're right, it would be low. You're correct. Your mind is working perfectly. Let's see what you got.
I could figure out that way.
So where's the part? Which one's the part?
The 124 is the part.
Okay, so you just need to set it up as an equation. P equals decimal percent times the whole. P, the part, is what? What are you trying to find? What's the whole? Yep. Now, how do you get x by itself? No, you always divide by what's with the x. These are the same equations from like 3 weeks ago. You aced that test. You know exactly how to do this. This is an equation. You got to do the opposite operation. If we're multiplying by 496, that's it. It's one problem. You do one division problem, you've solved it. That's it. Instead of cross multiplying, then dividing, you're actually doing more work and it's harder than this. Yes.
Well, I need help. I'm not learning.
So what's the part?
I'm not showing this
The part's always going to be your what?
smallest.
Yes.
So it's
Shh. All right, let's do this together. Let's do this together. Part, whole, decimal percent. First and foremost, what do they want you to find? Yeah. They want us to find the percent. That's x. That's my unknown. Okay? What is my part? Yeah. Hannah Harvey. 124. Your part almost always is going to be your smaller number. What about your whole? Yeah, Anna? 496. Okay. I just plug it in. Okay, so let me copy my equation. Here we go. The part is 124. The decimal percent is x. The whole is 496. Anytime I multiply a variable by a number, I can rewrite it like this. That's the same thing. How do I get x by itself? Gretchen. Divide what?
496.
What happens to my 496s on the right-hand side? Savannah? They cancel. And I'm left with 0.25, which equals x. Now, 0.25 is the decimal percent. It's really what percent? 25%.
Is that how you do it?
Yeah, that's it.
So is it just like those other problems but backwards?
It's similar. There's less work. You don't have to worry about cross multiplying, which is, you don't have to worry about the 100. You don't have to worry about setting it up right. Because the other way is what makes this work. Because the other way gets your brain in the habit of looking at fractions as decimals and the 100, and it's practice. Stop. 5, 4, 3, 2, 1. All right. So when you're solving problems like this, if it says use an equation, this is what you do. If it says use a proportion, you use the other method. Okay? There are times when the proportion is easier. There are times when this is easier. I will tell you, though, that as an adult, most of you will use this method, especially when you're trying to figure out tips or sales. Okay? I'll give you one more example of this. Let's say that I'm trying to buy a coat that is $75.99, but it's on sale for 20% off. So if I was in the store, this is what I would do. I would say, to find how much I'm going to save, I just do 0.20 times $75.99. And that gives me my part. Okay? So what is that? What's 0.2? It's going to be roughly 15 something, 15, 16 bucks. Somebody? 0.2 times $75.99.
Oh, I can think, Mr. Boheimer, I can think this in my head. I got it.
What do you got, Hannah?
15.19.
So 15.19, so $15.20. So $15.20 is the part. Okay? Because I took the decimal percent and I multiplied it by the whole. All right? So that means that in this particular jacket, I'm going to save roughly $15, which means that I'm going to pay $60 instead of $75.99, roughly. Which is a lot better, right? If I can save 15 bucks, I'm definitely going to save 15 bucks. Yes. Because you can't do proportions on a calculator. I can do one multiplication problem on a calculator easy. So if I pull out my phone, what's easier? Setting up two proportions, cross multiplying, and then dividing, or one number times another number? One number times another number.
Wait, so now there's three different ways to do it?
No, this is the same way I just showed you.
Wait, then, yeah, my question, why would you do 0. Why don't we just do this instead of doing the proportion thing that we just did? Like,
It depends on the way the problem's set up. That's all, the only reason. We show you, like for instance, why does the mechanic have 16 different types of screwdrivers? Because depending on the problem he's facing, he needs a different tool. You guys need 3 or 4 different ways to solve percents. So depending on the way it presents itself to you, you have multiple tools in your pocket.
should we use that for these?
Yeah. Hey. 5, 4, 3, 2, 1. The question on the table is, why do you have to learn all these ways? If you're a mechanic and you're facing a problem, you're trying to fix a car, right? As a mechanic, you have a dozen different types of wrenches, you have a dozen different types of screwdrivers, pliers, etc. Okay? When you are working on something, when you are working on a car, you need multiple tools so that depending on the problem you're facing, you can pick from those tools the tools you need. You will be faced with, at some point in your life, multiple situations where you have percents and decimals and things like that. Mr. Pennekamp testified to it yesterday. His teacher made him memorize some of those common percents, and they were very useful to him. I give you these tools so that depending on the problem you're facing, you know how to approach it, okay? So, in a problem situation like this, I took the percent, turned it into a decimal. The decimal percent times the whole equals the part. It's the same equation we've been working with all hour. And as a result, I just did one multiplication and I found my part. Sometimes you're given the part. You will always be given 2 of these. It doesn't matter which 2. Maybe sometimes it's the decimal percent and whole. Maybe it's the whole and the part. Maybe it's the part and the decimal percent. You have to find the whole. You can use this 3 different ways, but it's the same equation.